Hello. It's quite late, so thank you for being with us and listening to us. I'll be talking about the rat results of the same study group. We initiated this together, and I'm going to give you some information about the animal leg. We conducted tests on animals because all these neurohormones are synthesized and released in the hypothalamus, and these hormones, peripheric responses, whether they have an impact on the brain activity, was something that we were interested in. These neurohormones, whether they are expressed in the brain or not, is quite contentious still in the literature. So very briefly, let me tell you about these mechanisms once again. Actually, the previous two speakers, Süleyman and Mehmet, talked about these, but still. Now, in this slide, what I would like to say is all these signals related to appetite and food intake is actually interpreted in the hypothalamus of the brain, and these have an impact or determine behaviors vis-a-vis food and nutrition. This is like a tripod, fatty tissue and digestion system, and the main component or the studies that focus on the most important leg of the tripod, i.e. the brain, are rather recent. Although we need to focus on the brain, actually, we know the least about the brain, so we need more studies. In addition to appetite and digestion system, we need more studies on the brain. As for the biology of eating in the brain, there are three types of behaviors: hedonic, homeostatic, and integration. So these are the three systems at play in the brain, and this is the hypothalamus and the other dopaminergic and serotonergic pathways, and these have an impact on our eating behaviors. Of course, this is rather a summary. So weight gain related to antipsychotics were deemed to be stemming from these two pathways for a long time. But as Dr. Süleyman also said, the different mechanisms seen in aripiprazole in different patient groups tell us that we need to also look at hypothalamus. Dr. Mehmet, my colleague, talked about hypothalamus, central energy mechanisms. This is like a controller that regulates energy intake. There are different nuclei here, different areas, and within these there is the arc nucleus, which regulates energy intake. And just like in humans, in rats as well, there is almost the same system. That's why we worked with rats. These are candidate genes, PAMC and AGRP, CART, and NPY. On a gene level, there is a similarity on a 95% scale, and in terms of protein there's an 80% similarity. That's why we thought rats to be a good model for us. In the rat studies, we use olanzapine and risperidone, just like we did with the humans. Olanzapine as a potent weight gain feature. Risperidone is associated with moderate weight gain, and they have a 5-HT2C and D2 receptor affinity. These are both antipsychotics. In the rat study, we used Wistar rats because this this is the only species that we could get hold of in Turkey. There are other species, of course, but these blister rats are rather resistant towards weight gain, but that's all we could find. The medications were given orally, again based on their weights, twice a day, especially for olanzapine, and risperidone likewise twice a day, administered orally. And of course they did not want to get these medications, so we mixed them with sucrose. They love sucrose, so they didn't care about the risperidone or olanzapine content of the sucrose. And we did not lose any of these rats. They loved it. For 4 weeks, for 33 days, we kept an eye on them, and their diets were also quite regular. There were 3 rats in every cage, and their daily food intake and water intake were identical. At the end of the 4th week, we had to sacrifice them, and their brains were taken out, and total hypothalamus were also taken out. And in these hypothalamuses, gene expressions were observed, and how they reflect on the periphery was also observed. For this, in order to see the gene expressions, RNAs, total RNAs had to be isolated, and we had to keep them in protective solutions. We did not let them to break down, and we ran all the tests, and of course I can't give you the details right now, but the RNAs that we extracted were reliable. They were total RNAs, and then we converted them into DNAs to make them more resistant, and then we performed quantitative real-time PCR, and we looked at their gene expressions as such. And also, after we decapitated the animals, we collected the blood and we prepared the plasma, and using the ELISA method, we looked at the content of these hormones in the periphery. Weight gain in animals, rats, vehicle that only received sucrose, and the group that only received medication, that's black. This is the weight gain over the course of 4 weeks. And in these graphs you see the content of the food that they consumed on a daily basis. You see how much food was given to the animals. In terms of weight gain, there is not a statistically significant increase, but there's a tendency towards weight gain. Of course, this is a 4-week study. It's quite short, especially for blister rats. It's quite a limited period. Just like my colleague Mehmet said, they demonstrated weight gain in 4 days, but in our case it wasn't so imminent. And as for these slopes, sucrose receiving animals versus olanzapine group, between the two groups in terms of food intake, there's a difference, and this is because of the food increase in the food that causes the weight gain. And again, this is translated into their gene expression, which I will show you shortly. For the olanzapine group, this was for the olanzapine group. For the risperidone arm, we had the same picture. There is not a significant increase, but still there is an increase compared to the control group. In the food intake, there was an increase. These animals, their internal organs were also collected, and when we dissected them, we saw that in the control group, there wasn't intra-abdominal fat formation, but in olanzapine and risperidone groups there was intra-abdominal fat formation. These results, gene expressions, showed a change in gene expressions. Vehicle is for V is for vehicle, that's the control group, and then MPY, AGRP, and CART expressions variety are shown. All of these are, save for AGRP, these are all statistically significant. We looked at how many fold gene expressions increased for us when we compare gene expressions, one-fold. If there's a one-fold increase for us, that's significant. And here in PALM-C, there's almost a threefold change. And as for MPY, there's a twofold increase. And as for CART, there's a twofold increase. As for PALM-C and MPY, there's a decline. That's significant. But the increase in CART cannot really be explained. But of course we discussed this amongst ourselves, and we thought this was because CART also has an impact on the reward mechanism. It alters that mechanism, so maybe it has to do with that. The previous one was for risperidone, and this is for olanzapine. In CART, there is no change, but in the other candidate genes, there's a significant gene expression change that we observed. Similarly, how is gene expression is this reflected on the periphery? We looked at that too. In these animals, there wasn't a significant increase in weight, but in leptin levels there was an increase, and this is correlated with fat formation in the periphery. As for the responses, AGRP and pumps, alpha MSH was checked, melanocortin stimulating hormone, and there is a difference here, and in CART as well. In the risperidone group, in NPY, there was not a difference. Also, in the olanzapine group, leptin levels were higher, but not statistically significantly so. In all the other candidate genes, in terms of gene expression, we saw that this was taking place in the periphery as well. So the responses that we observed in humans correspond to the ones in the brain, say for AFSMH. Again, a comparison between risperidone and olanzapine. In these candidate genes, in gene expressions, in mRNA levels, there's a decline, and it corresponds to the decline in plasma levels, and this was quite a welcome result for us. This has to do with our hypothesis. Dr. Mehmet actually walked you through this, but in the animals that received this medication, first of all, their brain mechanisms were altered, and this increased the adipose tissue, and with that, leptin levels were also elevated, and this was rather like a vicious cycle that continued. Antipsychotics actually have this effect, but this actually emphasizes something very important. Adipose tissue and leptin increases with excessive weight, it was thought, but now we know that the mechanisms in the brain change first, and this is what changes the adipose tissue. This tissue is changed because of the signals coming from the brain, it is said now. Adipose tissue leptin levels are shown here. When there's an increase, POMC and CART neurons are subject to an interaction, and as Dr. Mehmet, as my colleague said, cellular mechanisms are changed and CART levels are elevated, and MPY, AGRP levels are also reduced. Finally, the reason why we did this was to make sure that we had similar results in animals, and we also wanted to see whether the findings in the periphery would correspond to the findings in the brain, in the central. If we are to compare humans and rats, BMI and leptin increases in humans, but both trended high in rats, but not on a significant scale. In both drugs, the candidate genes resulted in high hypothalamic expressions of alpha MSH in humans and rats. But in rats, there was a bit of a difference. And also in rats, alpha MSH decrease in both gene and protein expressions. After we did this, we started devising a new study, metformin. This is an agent used against weight gain for patients that are on antipsychotics. It's used widely, and we will continue to work on this. And for this, currently we are looking at the food intake of the animals and weight gain of the animals. We have some data. There are 5 different groups in animals, and this time around the medications were given for 7 weeks instead of 4 weeks. And after 7 weeks, metformin was given for another additional 7 weeks. In the first metformin group, within this group, there's another group, olanzapine plus metformin group. For 14 weeks, we olanzapine 7 weeks, and then olanzapine plus metformin for the next 7 weeks. So the rats were put on metformin after the weight gain, and then metformin is given from the beginning and is administered for 14 weeks. When we compare the meals, olanzapine 3, metformin plus olanzapine, food intake compared to the other groups was the lowest. And similarly, olanzapine 2, metformin plus metformin after 7 weeks also reduced food intake, but the highest effect is seen in the olanzapine 3 group that received olanzapine from the get-go. These are mean experimental group weights versus weeks. We looked at different weeks. Weight gain per week was determined and compared. As you see, after the 7th week, you get a difference in weight gain. For Wistar rats, this is to be expected. It's quite normal. Weight gain starting from the 7th week, it was something that we wanted to see. At the end of the 14th week, olanzapine 3 group, to repeat, it is the group that received metformin from the very beginning. Weight was the lowest, and actually this was self-evident starting from the 7th week. As for conclusions, olanzapine administration to the rats resulted in weight gain compared to olanzapine plus metformin administered rats. Metformin decreased the appetite in all these groups, and use of metformin was trended to be most prominent when it was used from the beginning of the treatment. Of course, these are quite substantial findings for us, but what's more exciting is that we will be embarking on new studies in the future. Well, actually, we have done certain studies, but we haven't received the results yet. We are now, this time around, focusing on more potent expressions like NPY and POMC. Again, it's going to be a real-time PCR study, and this time around we will look at protein levels in hypothalamus. That's the purpose of our next study. This study was quite important for us because sometimes we focus on a single molecule or a molecule, but in order to get down to the cause of the problem, we need more cooperation and we need a wider approach. And that's why we are doing these studies, and we are happy to work with our colleagues, other specialists, other professionals. So this is the team at METÜ. Postgrad students, Deniz and Canan, they have completed their master's degree, and metformin study was carried out by Gizem. And also we are cooperating with Mehmet, Levent and Süleyman, our psychiatry clinic, and we are very happy to do so. Thank you very much for your attention. If you have any questions, I'd be happy to answer them.